All right, next I'd like to look at some possibilities for time travel. These are, of course, some are speculative, some have been shown to be the case. And so with time travel, we know that we can do forward time travel. Been there, done that. So you can go into the future. Now, how could you do this? Well, you could just fly close to a black hole. We've already looked at this possibility. And then you would age more slowly than the rest of the universe. So even though from your own point of view you would seem as though you're aging normally, you would go back, say, to the Earth, and the Earth would be much older. And so we saw this with the starship captain who flew too close to the event horizon and then came back. You may recall she was 10 million years in the Earth's future when she got back. Okay? And so this kind of thing then, you go, well, that's just theoretical. But no, it's not just theoretical, because our GPS system, our satellites, are farther away from the Earth than you are on the surface of the Earth. And so if you have an atomic clock here, you have an atomic clock up here in your GPS satellite, that clock is going to be ticking off more slowly than the clock is on the Earth, because you're farther away from the gravity of the Earth. So this is basically the same idea. Okay? And so time goes, I should say here, this is less time, sorry, this is more time. Because closer to the Earth, you're going to be, essentially this would be like being closer to the event horizon of a black hole. This would be like being farther away. So the time clicks off faster, farther away from the Earth. And so if you don't account for this, you get the wrong answer with your GPS locator. Okay? And so it'll drift. It would drift as much as maybe 20 feet a day or more if you don't account for general relativity. And so this is being proved then. Essentially, this clock is going into this clock's future. And it's happening all the time. And if you don't correct for it, the GPS system doesn't work. Okay? And so this is being proved over and over again. This is not just some crazy idea that Einstein came up with that's theoretical on the back of an envelope. It's being proven every day. Another way that you can go into the future, forward time travel, is to just fly really fast. To a nearby star and then return. And so what Einstein's principle of special relativity tells us is that as you travel very rapidly to a nearby star, the length of that distance is contracted relative to your point of view. And so you see less time clicking off than the Earth sees in watching you take that same trip, because from the Earth's point of view, you still have to travel that uncontracted distance. And so that takes longer. And so this is another way of going forward into the future. Another way of doing time travel. Any kind of acceleration will do this too. So you could be spinning around in a circle, but that would make you really dizzy, so that would be my least favorite way of doing it. But getting close to a massive object, flying really fast, or accelerating. Those will all send you forward in time. But what about backward time travel? Is that possible? Well, if we look at a lot of our science fiction movies these days, you would say, well, absolutely, I see it all the time. But we have to say, at this point, we don't know whether it's possible or not. But it creates problems. It creates a lot more problems than forward time travel does. And I think that I'm safe in saying that most reputable scientists would tell you that backward time travel is impossible. Okay? But we shouldn't give up because it's a really cool idea. But it creates, and let's look at the problems that it creates. What kind of a problem could it create? Well, maybe the most important is what we call a temporal paradox. Or sometimes this is also called a causality violation. So both of these are kind of synonymous. Temporal is time. Paradox means that there's some kind of a conflict in logic that's going on. Something doesn't make sense. It conflicts with some basic idea. And causality violation means that cause and effect are getting messed up. And so let's see what could cause this. Let's imagine that you have a little time machine and you can go backward in time. And so you jump into this thing, and this is your hypothetical time machine. And so you go back, let's say 100 years. So this is 1920, the time of the last pandemic. I don't know why you want to go back to another pandemic. But go back to 1920. And then here's your great-grandfather standing there, and you accidentally land on top of him, and you kill your great-grandfather. You didn't mean to, but it just happened. And this is, by the way, before he met your great-grandmother. And so what does this mean? Well, it means that the sequence of causal events has been interrupted in a very important way, because you go, okay, well, that's just fine, you never existed. But the problem now is, if you never existed, then how could you have gone backward in time to have created this event in the first place? It's impossible, right? That's what we call a temporal paradox, because there's a conflict there. It's impossible to have done something that has already occurred if you create a situation that prevents that situation from having ever happened. Okay? And that's also a causality violation, because how could you have created that effect, that causal effect, if your very act of doing it prevented you from having made the trip? Okay? And so these are the kinds of things then that, but it's not just a matter of being really careful. Like we've seen this kind of thing before, say on Star Trek. You go backward in time, you go, well, we've got to be super careful because we can't change anything that'll affect the timeline, or else there'll be catastrophic results. Okay? But it doesn't work that way either, because everything is chaotic, and so the slightest little disruption in the past we believe will magnify on itself to create what we call the butterfly effect. And so just stepping on a butterfly back then, or running into a microbe, or just changing the path of the wind velocity in one part of the planet by walking around could be enough to completely destabilize the entire timeline. And so we don't think that it's even on the level of, oh, we've got to be really careful. It's beyond that. Things are just too unstable for this kind of time travel to occur. However, there have been some scientists, one of them most notably Richard Feynman, who tried to come up with a possible solution to this problem. So one is that what you do naturally becomes a part of what's already occurred. Okay? And so you smoothly blend in with the past. So you become what has already happened. And as a matter of fact, this would mean that you were kind of, you were fated to go backward in time. You were required, we could even say, to go backward in time to have made the past as it ended up being. And so here's how we could state that. What you smoothly become part of what has already happened. And so what do I mean by this? Have I lost my mind? How do you become smoothly part of something that's already happened? Well, here's an example of a way that this could happen. And this was, by the way, dreamed up by Richard Feynman, one of the greatest physicists in the last century. You go backward in time, say 10 years. And then you try to kill yourself, okay, with a gun, let's say. You're going to experiment on yourself because you don't want to endanger anybody else with your wild, crazy ideas. And so this is yourself 10 years ago. So here you are, you're taking aim, you squeeze the trigger, you fire, but you shoot yourself in the arm. And so you don't kill yourself of 10 years ago. But the reason that you missed is that you have a bad arm. That some sniper shot you 10 years ago. And you have a bad arm. Okay? And so this then would be self-consistent, because the act of you trying to kill yourself 10 years ago created a problem in your arm that prevented you from having killed yourself 10 years ago. So you smoothed out the whole problem. Okay? And so that's one possibility. Here's another one. Here's another example of how this might work. Let's say that you have some kind of a time machine. It looks like a police call box from the 1950s. This would be a Doctor Who type of time machine. These things, by the way, are very cool. They're bigger on the inside than they are on the outside. This thing just looks like a little police call box, but on the inside it's as big as a city, according to the science fiction stuff. And so let's say that you're walking along and you need to make a phone call. Your cell phone's dead. And so you go inside and you notice the multidimensional technology, and you're quite blown away by that, but you're Still just trying to make a phone call. So you hit a few buttons on the console there, and this sends you backward in time by 45 seconds. Okay? But before you were sent backward in time by 45 seconds, you see some guy that's dressed just like you, and it looks very mad. And he's coming at you, and he hits you over the head at the moment that you hit the button to send yourself backward in time by 45 seconds. And so you're clobbered, you're almost unconscious, you hit the button, and you end up in the bushes 45 seconds earlier. And so you slowly wake up, and you go, gosh, what happened? And then you see yourself walking toward the time machine. And so you go, that's him. That's the guy that hit me. And so you're a little bit out of your head and just enraged. This guy, who is you 45 seconds ago, starts hitting the buttons. Then you, in a fit of anger, come running in there and smash him over the head. He disappears. And that's it, because that was the loop that you experienced. Then this guy, I mean, you could say, well, this just keeps happening, but not from your point of view. You would just see this happen once, and then you go, boy, I better not tell anybody about what just happened. And so you go on with your day. So that would be another self-consistent interaction that could allow for you to become a part of what has already happened. Okay? And so that is a possible solution to the time travel problem. Whether or not you're actually able to find that kind of a solution to Einstein's field equations that is acceptable and that has a high enough probability of occurring is another question. Some people think, well, yeah, maybe this kind of a thing is possible because of that butterfly effect. It would be so unlikely that you might have to wait 100 billion times the age of the universe just to see something like that happen once. So if that's the case, if the only way to become smoothly a part of what's already happened is to essentially beat the laws of probability, then that means that essentially it's never going to happen, even though the laws of physics don't prohibit it. And so that is another thing that we should think about here, is that time travel might be possible, but highly unlikely. Another way that has been dreamed up of overcoming this problem with causality violations is to say that at each moment, this is one theory as to how the universe evolves, is that it just keeps branching off into parallel universes. And each time that there's a chance of something happening a different way, it does happen that way. It happens in all possible ways, but in parallel universes. So if that's the case, if that is the kind of a multiverse that we live in, then you might be able to go backward in time to another parallel past. You could mess up that timeline and it wouldn't affect you having made the trip. But we can see that these kinds of solutions are going to be difficult to justify at best. And so this is something that we should be aware of, is that when people talk about backward time travel. There is no good, solid scientific justification for it at the present time. And we're going to need to evolve a new kind of an understanding that involves unifying quantum mechanics and general relativity before we're going to know for sure.